and welcome to the panel discussion about cloud-based artificial intelligence for pollution prevention at Yorkshire Water. I'm proud that we can demonstrate you today an interesting and realized use case together with our partners from Yorkshire Water. They will talk about their experiences with this digital solution. We are going to talk about an outstanding project in the area of sustainability, and we are very happy to have Ben Roach and Heather Sheffield from Yorkshire Water with us today. Ben Roach is the Director of Wastewater at Yorkshire Water, and Heather Sheffield is there the Operational Planning and Technical Manager. And last but not least, we are glad to welcome my colleague Adam Cartwright in our panel discussion, who is Head of Digital Water Solutions from Siemens in the UK. We want to start with Ben and ask him about the challenges his company has to face with the sewer management system. So Ben, can you please give us a big picture of the situation in the UK, especially in Yorkshire?
Yeah, sure. Thank you. Well, of course, the water environment is hugely important for all of us in the UK. Not only is it key in terms of supporting the aquatic environment, it's increasingly become a source of recreation. Many of some of the iconic towns and cities that are based on rivers in the UK. But of course, it supports development, prosperity, and is hugely important. I guess recently we've had the David Attenborough revolution with the kind of campaign against plastics. And that's led really now to a focus on the water environment in general. But of course, we have some legacy infrastructure in the UK. We have around 570,000 kilometres of sewer. 53,000 kilometres of that is in Yorkshire, in my company. And of course, it can be viewed as an occupational hazard at times when there is an escape from the sewer network. So we're very focused on reducing pollution. It's becoming a hugely topical matter for our customers. It's in the media all the time. So we are committed to reducing the potential for pollution, and we've made great strides in the UK. We've you can see, particularly in Yorkshire, where our company is based, we've improved former industrial rivers where there was limited aquatic life. We now can see spawning and migrating salmon and trout, which is amazing to see. We can see otters pretty much in every county across the country. But of course, we need to do more. Pollution incidents and water companies, the numbers are still far too high. I think last year we had over 2,000 pollution incidents across the UK from water companies. Whilst those incidents that become very serious are still very low, actually 2,000 is far too high, and we need to do more. So what do we need to do? And I think Siemens holds the key for us. I think technology has a huge part to play. We're not going to deliver huge improvements by replacing our sewer network, but what we have to do is be smart, look at monitoring, and understand in real time where the risks are on our infrastructure. And I think that's what we've learned so far from this project, is the potential of working with a great partner on how we can deliver that environmental improvement.
Thank you, Ben. Glad you took the time to join us and share your valuable insights with us. As we will see in the next half an hour, there can be something done about this. Yorkshire Water has managed to improve their sewer management, and based on that, improved the waterway protection. Heather and Adam, welcome on stage. Heather, can you please tell us something more about the project and the goals of Yorkshire Water?
Yeah, sure, absolutely. So Yorkshire Water has just entered a new asset management period where we have some very stretching performance commitments. So we're regulated by a company called Ofwat, and we work with them to produce a business plan. And our next period, which runs for 5 years, has set some very stretching pollution performance targets. So we've looking to reduce pollution to the environment by 41% over the next 4 years. So it's really driven us to look at new ways and look at innovative solutions to help us to predict those pollution events and intervening before they occur. So this is where understanding or looking at the telemetry within our network and understanding where we can use that data to more effectively model and understand where we may be having problems, and then raising a proactive response from our field staff to prevent that from happening. So we've been working with Siemens to implement an artificial intelligence solution, which is known as the Zebra blockage predictor, to help us to do that and deliver that change.
Thank you very much. So, how was the collaboration between Yorkshire Water and Siemens?
So this project, without Siemens, we wouldn't really have been able to productionize, if you like, the research that we've been doing with the University of Sheffield, which has been ongoing now for several years. But it wasn't until we collaborated with Siemens to turn that research into, I guess, reality and a tool that we could use. So we collaborated closely with Siemens, from people within my team, to develop that product so that it was user-friendly and something that would help us in our day-to-day operations from a control room perspective, and sort of use that intelligence, as I said, to communicate with our field and go out and prevent those pollution incidents before they occur.
So, thank you, Heather. Let's have a closer look to the solution itself. Adam, you were the project lead from Siemens. So can you give us some more information about the technical background of the solution?
Certainly. So if you're looking to avoid pollution incidents, you really want to understand those potential places where it can come from your network. And the two in Yorkshire Water that we've looked at are combined sewer overflows and manholes. Now, monitoring those two egress points is a challenge for two reasons. The first of them is that spilling from those is not necessarily a problem. That's normal operation. So any alarm based on threshold alone will give you a lot of false alarms and not pick up the building issues which might be in the network. The second challenge is that combined sewer overflows are complex. Is it hilly or flat, urban or rural? What's the upstream or downstream network like? All these factors make it difficult to use a single statistical approach like rate of change or rolling average to detect an issue. So that's why we used an artificial intelligence approach that was able to learn the complexities for how these combined sewer overflow and manhole assets responded to rainfall. And in this way, we're able to identify if the level we're measuring in those assets worked or if it didn't. Now, importantly, our design approach for this was to try and make it as simple to deploy and scale as possible, which means we don't need hydraulic models, we don't need network information, we just need to understand the level at that measuring point in the combined sewer overflow or the manhole. Now, as Heather mentioned, from a user's perspective, the feedback from them was that it was really important that they didn't need to see or understand the complexity of the underlying artificial intelligence. So that's why we have an easy-to-use cloud application that provides notifications and enables more detailed exploration of the data if needed.
You're talking about cloud application. Cloud applications have been used in other industry quite for a long time, but the water industry is very hesitant about it. What is the compelling argument for Yorkshire Water to step towards the cloud application and to go into the cloud?
Hey, that's a really good question, Axel. And in many industries, cloud is used regularly for many applications for monitoring and control. And in water, it makes sense for some things, but not everything. And one of the main reasons for that is here we are talking about critical national infrastructure. So cybersecurity risk is really, really important. So UK water companies, not just Yorkshire Water, but all of them, spent a lot of time working with the cyber security authorities in the UK to assess when they can safely and securely use cloud and when they shouldn't. So this solution ticks all the right boxes. First of all, it's monitoring and not control. So the risk from a compromised system would be low. Second, we're using the MindSphere platform. This is a mitigation. So MindSphere is Siemens Internet of Things platform, and it's based on Microsoft Azure, AWS, or Alibaba. And it's specifically designed to connect into operational technology. And it's used by blue chip companies in lots of sectors all over the world. So when we've designed it as Siemens, we built it in a way that has cybersecurity at the heart of it. So MindSphere gives us a secure development environment. The third thing was we then made sure that we have a robust product lifecycle management approach. And this is knowledge and experience gained from across all different parts of Siemens. So this means the way in which we build and maintain the application ensures that we manage the cybersecurity risks throughout the lifecycle. So while the risk is low, we've also got really robust mitigations in place, which then leaves us to consider the benefits of cloud. And there are many. That's why we want to use it for this application. Cloud allows us to draw in different data sources, in this case, rainfall radar data. It allows us to scale up the application to potentially thousands of assets in a relatively low-cost way. It allows easy access for users on multiple different devices, and it improves the interface to multiple IT systems. So, for an answer to your question, Axel, cloud, if you manage the risks right, is usable. And in this case, it definitely is, and it brings lots of benefits.
Thank you, Adam. This sounds really straightforward. So let's talk about the results. Heather, has the application worked as you have expected it?
Yeah, so absolutely. The application, as well as being incredibly user-friendly and brings with itself efficiencies for my team, when we've looked at the results and compared it to our existing processes and some of the research we'd done previously, the University of Sheffield carried out a really big piece of work to validate the work and the outcomes and the results in that way. They really, reviewing that historical data help us to show that the new tool with Siemens improves our pollution prediction by 3 to 4 times more effective and better at predicting a failure. It also means that we have a lot less what we call false positives, so going out to carry out work on the network where it may not necessarily be required, and that's down to 3%, which is a significant improvement on our existing processes. So again, brings huge field efficiencies, helps us to better predict pollution and prevent that as well. The University of Sheffield has really given us the confidence in the solution and means that we're taking it forward to a full-scale rollout across our network, which will again help us on our journey for that significant environmental improvement and the pollution reduction.
Thank you very much. That sounds amazing. Adam, this sounds also that we should have a good basis for scaling up this application.
Yeah, I think Heather made a really important point there, which is co-creation is really important. It's about building trust. But then sometimes when you're both so involved in something, it's really helpful to have someone from the outside come and independently look at that. And so we held our breath while the University of Sheffield reviewed 21,000 days of data. And we were delighted to find that the AI worked as we all hoped it would. And it actually found 9 in 10 of the issues that were in the data. The AI found those needles in the haystack. So I think we were delighted to be able to keep working with Yorkshire Water and to be able to help the ongoing development of the application. And what you talked about cloud earlier, one of the great things is this means it is now so scalable and deployable elsewhere. as we take this not just for UK customers, but also for global customers too.
Thank you very much for these interesting insights in this project. This project shows that artificial intelligence is not magic. It requires people who really understand the issue, experts in data science and engineers who can build software, connect hardware and create a solution that is secure against cyber attacks. This project is a textbook example of how all strands should come together. Thank you so much for sharing this with us.